Hello everyone. Welcome to UIS. Let's discuss today important topic. The science behind a nuclear bomb is based on nuclear reactions, specifically nuclear fission and or nuclear fusion. About the last week's Christopher Nolan's blockbuster Oppenheimer has ignited conversation on the history of creation of these weapons and the ethical dilemmas involved in their use. But what is a nuclear weapon to begin with? What is the science of the bomb and from where does it get its terrifying power? What engineering and scientific capabilities and natural resources must be harnessed to create this modern miracle of science? Atoms are the basic building blocks of all matter, such that they cannot be broken down further by simple chemical processes. From our bodies to the air we breathe, everything is made up of atoms. Atomic structure of lithium-7, which has 3 protons, 4 neutrons and 3 electrons. Most of an atom is empty space. The rest comprises 3 basic types of subatomic, smaller than or occurring within an atom, particles, positively charged protons, negatively charged electrons, and the neutral neutrons. The protons and neutrons combine to form the atom's nucleus, around which circle a cloud of electrons. The number of protons in an atom determines the element, and the number of neutrons determines the isotope of that element. Different isotopes of the same element have the same chemical properties, but very different nuclear properties. When a nuclear device is actually exploded, exactly what happens? Nuclear weapons are thousands, if not millions of times more powerful than conventional explosives like TNT. Upon explosion, they produce 4 types of energy. A blast or a shock wave that can flatten and obliterate any physical structures in the blast radius. Bright light, which can cause permanent blindness even many kilometers away. Intense heat, which can literally turn human bodies into ashes in an instant, and radiation, which includes both initial radiation, produced within a minute of detonation, and residual or delayed nuclear radiation, which is emitted over a period of time. There are 2 main types of nuclear bombs: atomic bombs, fission bombs, and hydrogen bombs, fusion bombs. Atomic bomb, fission bomb. The basic principle behind an atomic bomb involves nuclear fission, which is the process of splitting the nucleus of an atom into 2 smaller nuclei, releasing a large amount of energy in the process. The atomic bomb typically uses fissile materials, such as uranium-235 or plutonium-239 as the fuel. The process begins with the assembly of a critical mass of fissile material. When enough fissile material is brought together, a self-sustaining chain reaction occurs. Neutrons are fired into the fissile material, and when they collide with the atomic nuclei, they cause some of the nuclei to split, releasing more neutrons and a tremendous amount of energy. Neutrons are fired into the fissile material, and when they collide with the atomic nuclei, they cause some of the nuclei to split, releasing more neutrons and a tremendous amount of energy. In a matter of microseconds, an immense release of energy occurs, resulting in an explosion. The energy released can be in the form of intense heat, pressure, and radiation. Hydrogen bomb, fusion bomb. A hydrogen bomb, also known as a thermonuclear bomb, is much more powerful than an atomic bomb. It is based on nuclear fusion, which is the process of fusing 2 light atomic nuclei to form a heavier nucleus, releasing an even larger amount of energy than fission. Hydrogen bomb, fusion bomb. A hydrogen bomb, also known as a thermonuclear bomb, is much more powerful than an atomic bomb. It is based on nuclear fusion, which is the process of fusing 2 light atomic nuclei to form a heavier nucleus, releasing an even larger amount of energy than fission. The hydrogen bomb consists of 2 main stages: the primary stage, the atomic bomb, and the secondary stage, fusion stage. The primary stage uses a typical atomic bomb as a trigger. When the primary stage detonates, it generates an intense burst of X-rays that compresses and heats the secondary stage, which contains isotopes of hydrogen, such as deuterium and tritium. The extreme conditions created by the X-rays in the secondary stage cause the hydrogen isotopes to undergo nuclear fusion, releasing a tremendous amount of energy. The energy output from the fusion stage is several orders of magnitude greater than that of the fission stage, resulting in an exponentially more powerful explosion. It's important to note that nuclear weapons are extremely dangerous and have significant humanitarian and environmental consequences. Their use has been limited by various international treaties and agreements. The scientific understanding of nuclear reactions and the development of nuclear weapons have raised concerns about their potential for destruction, leading to ongoing efforts towards nuclear non-proliferation and disarmament. Thank you everyone. Subscribe to UIS channel.